Let's begin this lesson by getting a strong grasp of the general lens. A lens is an optical device that bends and focuses light. They are transparent pieces of glass or plastic with curved surfaces, and the curvature of the surface determines how much and in what direction the light will bend. Lenses are able to bend light because of a phenomenon called refraction. Refraction occurs whenever light passes from one type of material into another, during which the light waves change speed and bend. This allows the lens to form images, and so lenses are used in all kinds of optical instruments, from eyeglasses to projectors to microscopes. Lenses are classified based on the curvature of their surfaces. Those that curve inward are called concave, while those that curve outward are called convex. A convex lens is also known as a converging lens because it bends light towards a single focal point. Convex lenses can form two types of images, real and virtual. A real image is one that is projected in front of the lens and can be captured on a screen. Convex lenses are the only type of lens that can form real images. If you've ever seen a movie in a theater, then you've seen a real image created by a convex lens. Projectors, like those used in movie theaters, use convex lenses to project real images onto screens. Convex lenses can also form virtual images, the kind you have to look into the lens to see. Many people use eyeglasses to see clearly, and these often have convex lenses. If you're wearing glasses with convex lenses, you are always looking into the lens, so everything you see is actually a virtual image created by your lenses. You can calculate the type of image formed by a convex lens by using the thin lens equation. In this equation, S1 is the distance from the object to the lens, f is the focal length of the lens, and S2 is the distance from the object to the image. The thin lens equation can be used with all types of lenses, not just convex lenses. Note that when the equation is applied to a convex lens, the focal length will always be a positive number. Let's look at an example of how to use the thin lens equation. First, let's take a lens with a focal length of 0.15 meters and place an object 0.2 meters in front of it. What type of image will be formed, and where will the image be located? Use the thin lens equation to find the image distance, S2. What does it mean to have an image distance of plus 0.6 meters? Since the image distance is positive, the image is real and on the opposite side of the lens from the object. This is the type of image that could be projected on a screen. What would it mean if the image distance, S2, were negative? In that case, the image would be virtual, and you would have to look into the lens to see it. We can also use this information to find out something about how big the image will be. Once we know the image distance and object distance, we can calculate the magnification, m, which tells you how much bigger or smaller the image is than the object. A magnification of negative 3.0 tells you that the image is 3 times bigger than the original object. If the absolute value of the magnification is greater than 1, the image will be bigger than the object, and if it is less than 1, the image will be smaller than the object. The negative sign also tells you that the image is inverted, or upside down. A positive magnification would mean that the image is upright, so in this situation, the image will be real, inverted, magnified 3 times, and located 0.6 meters from the lens. Convex lenses are used in all kinds of optical instruments, like movie projectors, microscopes, and telescopes. But the most common uses of lenses are in eyeglasses and contact lenses that correct vision problems. If you have trouble focusing on objects that are near your eyes, you have a condition known as hyperopia, or farsightedness. This occurs because the lens in your eye cannot focus light on your retina properly, and the image forms behind your eyeball. To correct hyperopia, you can place a convex lens in front of your eye and make the light converge at the correct location. This allows a sharp image to be formed on your retina and restores your vision. A lens is a transparent piece of glass or plastic with a curved surface used to bend and focus light. When light bends at the interface between the lens and the air, it is called refraction. A convex lens is one that curves outward and has a positive focal length. It can form both real images that can be projected on a screen and virtual images that can be seen by looking into the lens. The thin lens equation can be used to calculate the location and type of image formed by a convex lens. In this equation, s1 is the distance from the object to the lens, f is the focal length of the lens, and s2 is the distance from one object to the image. A negative image distance tells you that the image will be virtual, while a positive image distance tells you that the image will be real. Using the information gleaned from the thin lens equation, we can also find out the level of magnification, m, which tells you how much bigger or smaller the image is than the object. If the magnification is a negative value, the image is flipped upside down, and if it's positive, it's right side up. Simple, right?